Go and look at that before we leave. All right. There we go. Number 15. Suppose that 45% of the people in a large community have type O blood. You take a random sample of 20 people from the community. Ooh, I'm going to circle that right there. If I'm taking a random sample of 20 people, then we have 20 trials. So this is going to be my N value. 45% of the people in the community have type O blood. That's a percentage. They're telling me P. Let X equal the number of people in the sample with type O blood. Determine whether each random variable described below satisfies the conditions for a binomial setting, a geometric setting, or neither. I don't understand. Determine whether the random variable described above, because they described our random variable X right here. So we want to determine whether this is binomial, geometric, or neither. So I'm going to use bins, and I want to see if it meets those conditions. Well, there's two things that I can fill in right now. Which things can I fill in automatically? N. N is 20, because we're sampling 20 people. What else can I pull in right away? Probability, P. 0.45. So what I need to know now is, does it meet the binary condition? Does it meet the independent condition? So binary, what do we think? Yes, success or failure. What would a success be here? Success would be type O blood. And so failure would be any other blood type. Do we meet our independence criteria? Yes. Why? One person doesn't affect the other. What's something else that I could argue on this one? Because I am sampling from my community without replacement, technically.
It says a large community.
It says a large community.
Probably passes the 10%.
So let's check to see what that 10% can do. Like, what's my minimum number in my population? And see if we think that it's reasonable that a large community would have more than that. So 10% condition, I'd be looking at 20 has to be less than or equal to 0.10 of my large community, because that's my total population. So the community would have to be at least how big to meet this condition? 200. 200 has to be less than or equal to my large community. Do you think if they're describing it as a large community, it probably has more than 200? Yeah, I wouldn't exactly describe the senior class as a large community, and that's well over 200. So I think this is a reasonable assumption to make. And so we meet binomial, we meet independence because of our 10% condition, yes. Give me just a second, sorry, 3 more letters, there we go. When do you know to check for the 10% condition? I would say anytime it's talking about sampling from a population where you're picking people out and you wouldn't ever pick the same person twice. Like in a sample of 20 people, you don't want one person counted 3 times. You're like, you just count as one. So we're sampling without replacement in that case. Anytime we're sampling without replacement, we want to check our 10% condition. If we're sampling with replacement, like we're putting the cards back in the deck, or I'm picking random numbers where it's okay if I pick the same random number twice, then we would have our independence met just automatically. But yeah, I would say as a rule of thumb, if you're sampling without replacement, so picking people out of the community and you don't want to count the same person twice, you should double check that 10% condition. All right, we have N, we have S. So, is this binomial? Is this geometric? Or is this neither? Binomial. Why is it not geometric? Yes, we are not taking samples until we find the first person with typo blood and then stopping. I'm going to pick 20 people. If I don't get anybody with typo blood in that 20 people, that's just the luck of the draw. I'm done at 20 people. So X is a binomial random variable. I would say it's probably a good idea, since they named the random variable. I would then reference that, because on some problems they'll have more than one random variable. And so we want to make sure that we're being really clear which random variable we're talking about. On a question like this one, could you get away with saying it's binomial because you showed that you checked all your conditions there? Yeah, but I would get in the habit, because I have definitely seen AP exam questions where there's more than one random variable there. So I'd get in the habit of writing that down. So in order to get your full points on part A, I have to see that you checked all the conditions. And then you could make a conclusion. Yes, it's binomial. Yes, it's geometric. It's neither of these. What we're really looking for on the neither, there has to be something in here that this does not satisfy to be a neither. It's either not binary. Like if I just wanted to know what are people's blood types, there's more than just two choices. There's O, there's A, there's B, there's AB. If there's more than just two choices, it fails the binary. If we check our 10% condition, like we're sampling without replacement, and we check our 10% condition, and it fails there, then it would have to be a neither, because we don't have that independence. Yes. Oh, sorry, I thought your hand went up. Part B, find and interpret the expected value of X and the standard deviation of X. So expected value would be the mean. And how do we find the mean for a binomial random variable? Yes. N times P. Our N was 20. Our probability was 0.45. And 20 times 0.45 is what? 9. Yes. And here, real quick, I'm going to pass those out so you guys can see exactly where those are and how they're labeled. Please don't write on these yellow pages, because these are the same ones that I pass out for every single test. So don't mark on them or I have to throw them away. Oh my goodness. Take one past the others back. I do need to recollect these at the end of the class period, but like I said, I want to make sure that you guys are super familiar with where everything is on here. There might be an extra one there. E meters is coming back in this stack. If there's 5, we'll survive, I guess. All right. So rules for the mean and standard deviation are formulas. If you look right here in this center box on the front page, got an extra one. I wasn't sure if there was an extra one there or not. So if you look at the far left-hand column over here, it says probability distribution. Discrete random variable, that's when they give us a table. Binomial distribution, geometric distribution. And then in the center column, they're telling you how to calculate the mean. In the far right column, they're telling you how to calculate the standard deviation. In that far left column, they're giving you the formula for how to calculate when it's the PDF. When you want to know for like, what's the probability that exactly 3 people out of these 20. You can do binomial PDF on your calculator, or you can calculate it just like this. This weird notation where it has an N on top and an X on the bottom, that's exactly the same as when we have that giant letter C. The giant letter C is how the calculator, how it looks on the calculator. This is also another standard notation for that, but this is just your C notation right here. And then again, they're showing you how to calculate for a PDF on your geometric distribution here. All right. To the best of my knowledge, those are the only things that you would need from the formula sheet for this test. It's just going to be stuff on that front page. All right, so there's my expected value. How would you interpret that expected value? I know the question didn't ask for it, but what does it mean?
The average number.
Yes. That's not wrong. It's not complete. That we get like a partially correct on the AP exam.
Average number of people tested if many tests are taken in this sample of 20 is 9 people.
Something along those lines. That's a little bit closer. So I would say if I take many samples of 20 people, if many samples of 20 people are taken, from this large community, on average, nine of those 20 would have type O blood. Would I expect students to have to explain or interpret what the expected value means in context on the AP exam? Yep. They're usually not just going to ask you to calculate that expected value. They want to know what it means. Same kind of thing with standard deviation. They'll ask you what the standard deviation is, and then they'll want to know, can you interpret this in context? So for standard deviation, for our variable x, my formula for that, you guys all have your yellow pages in front of you. What is that formula? Yep, n times p times 1 minus p, whole thing square rooted. So I have the square root of 20 times 0.45 times 0.55. Standard deviation. So n times p times 1 minus p, square root of all of that is 2.225. Ooh, I forgot something up above that I should have put there. Instead of just 9, I should say 9 what? 9 people. If you label these things, you're usually going to CYA on getting your context in there. Like, are you at least showing some understanding of what your context is here? All right. How would you interpret that? What does that mean? Yep. From the mean of, yes, there you go. So the number of people with type O blood in a sample of 20 from this large community typically varies by 2.225 people from the mean of 9 people. For the test tomorrow, should you know how to interpret expected value and standard deviation? Yes, you should definitely know how to interpret those. Okay, the last part, part C, I didn't leave myself a whole lot of room to do this, but I want to find the probability that x is equal to 12. Do you guys want me to do this the calculator way or the by hand way? Calculator. Is this a PDF or a CDF? PDF. So BINOM PDF. What values do I need to put inside the parentheses? NPX in that order. 20, 0.45, 12. Should I label those? Yes, please. NPX. And then you hit enter after you close your parentheses. And you should get 0.0727 if you take it out to 4 places. So 7.27%. So there's a 7.27% probability that in a sample of 20 people from this large community, I get 12 of them out of those 20 that have type O blood. All right, and then we want to know the probability that X is greater than 12. Does my calculator do greater thans? No. Eni, did you have a question?
Yeah. So every time you do binomial PDF, it's NPX.
Yes.
And then for geometric, it's
Just, yeah. I think it's PX or XP. I don't remember off the top of my head. Let me check. I'll have to look again. Like, I don't have it right in front of me, and I don't want to waste time looking at that. But we can go back and look at the last page in your packet where we took notes, and it'll tell you back there in those notes. All right, calculator does not do greater thans. Also, does calculator do just straight up less than? No, it does less than or equal to. And because we can't have parts of people, I don't really need to worry about something that's not a whole number, because I could never get 5.5 or 11.5 people with type O blood. Is this a PDF or a CDF then? CDF, so 1 minus the probability that X is less than or equal to 11. So I'm going to do 1 minus binom CDF this time. And then we do NPX. So 20.45. X is different this time. X is 11 because I want less than or equal to 11. So NPX. And I get 1 minus, when I did this on my calculator, I got 0.942 ballparkish. Yes. So about 5.8%. Yes. Is it a possibility? Yes. What I would be looking for on that is just, to bump it down to the next whole number. If it is not something that is discrete by whole numbers, then you can't really, we would have another way of calculating that. We would probably do a normal distribution approximation. So if I was talking about, distribution of dollars or something where I can have those decimal values, I can't split it up as easily as this. This would have to be things that have to come in whole number increments.
So if this were to say just less than, so would you not, you can't do the calculator way like this?
So if this had, like, if this notation right here said the probability x is less than 12, then I would have had to do probability x is less than or equal to 11. Yes. Yeah. Yeah, I wouldn't have to do the 1 minus part, but I would, since it has to be strictly less than 12, I would have to knock that down one number, because the calculator is always going to do the or equal to with that. I believe that's all the parts of number 15. What else did you guys want to look at? We still have 20 minutes. What other questions did you want to look at? Yep, I put it in my calculator. Huh? So that's where you put in the binom CDF. So second vars, and you scroll down until you see binom CDF. You got to, like, you'll have to open up parentheses and then do 20, comma, 0.45, comma, 11, comma. 0.45, 11. Let me double check on mine. Maybe I typed it in the wrong way when I made my answer key. Second vars. If I got the wrong thing up there, I apologize. Binom CDF. 20 trials, 0.45, x value of 11. Yep, you guys are right. Maybe I read the wrong spot on my page. I'm not going to make too many excuses for myself here. So, yep, 869. So 1 minus. So I get 0.13. What, 1, I think? Yeah. 13.1%. I apologize for my error before. For those of you asking how many questions on the test, the answer is 13. 13 questions on the test. And usually we have 10 multiple choice, so that's like 3 short answer questions. Oh, yes. Number 18? Absolutely. Number 18, Picard Partners is planning a major investment. The amount of profit, X, is uncertain, but the research department has provided the following probability distribution for X in millions of dollars. Find and interpret the mean or expected value of X. If you look on your yellow page for how to calculate the mean, it has this horrible looking formula. It has mu x equals EX, that just means expected value. And then it has this guy, that's an uppercase sigma, XI, or sorry, P, oh, never mind, I'm misreading things. XI times P XI, that's what your formula sheet says, right? Now, what does that mean practically? Does anybody remember what this symbol means? Sum. So we're going to be adding a bunch of things. This part back here says take the X value times its probability. So what we're going to do to find our expected value or our mean, I'm going to take the X value of 1, I'm going to multiply it by 0.2, plus take the X value of 2, multiply it by 0.5, plus take the X value of 4, multiply it by 0.2, plus take the X value of 10, multiply it by 0.1. So then I would have 0.2 plus, what would that be, 1? Plus, I think we've got 0.8. maybe I'm not doing this right. What is, yeah, that's 0.8. And 1. There we go. So the mean of x would be 3. And how would we interpret that? How would we interpret that then? What does x mean here? The amount of profit in millions of dollars, right? So when we say 3, we really mean 3 million. And these are on their major investments. So my interpretation of that would be if Picard Partners, I'm going to call them PP, if Picard Partners makes many, many, many major investments, all I've done right there, other than the many, many part, is I've restated what X means. X is my profit for major investments. So if they make many, many major investments, on average, they will profit about $3 million. And then we have standard deviation. You can do this one of 2 ways. You can do it by hand. It's small enough to do by hand. Or you could do what? You can do it on your calculator. Do you guys want me to demonstrate how to do it on the calculator? Right. On the calculator. Pull this guy up. You need to put some stuff in a table, so you have to go to Stat. And you want to edit your lists. So, Stat, Edit. You want to clear out whatever's there. Down L1, what do you put? X values. So 1, 2, 4, and 10, right? 1, 2, 4, 10. Arrow over to list 2. What do we put in list 2? Probabilities. So 0.2, 0.5, 0.2, 0.1. Question before we actually do this. Is this a valid probability model? Yes, because all my probabilities add up to 1. These are all the possible outcomes. All my probabilities add up to 1 or 100%. If the probabilities don't add up to 100%, it is not a valid probability model, and you can't find the expected value or the standard deviation. All right, I've got this stuff in my lists. Now what do? Stat over to calc. 1 variable stats. Hit enter. Yep. List 1 needs to be here. Frequency list needs to be list 2. So in your calculator, you guys have to do parentheses for this, right? Parentheses, L1, comma, L2. Close your parentheses and hit enter. Which one of these pieces is the standard deviation? Yes, this 2.53 is probably what I'd put there. 2.53. I will not. So I would write myself some directions and study those tonight. If you want to calculate this by hand, if you calculate sigma by hand, it's small enough that you could do this. And there is a formula on the formula sheet to do it by hand. So the formula on the formula sheet has that summation underneath the square root, big long square root here, summation, and then xi minus mu x squared times p xi. So what that is telling me to do is underneath this enormously long square root, I'm going to add a whole bunch of things. I'm going to take my x value, I'm going to subtract the mean, I'm going to square it, and multiply it by the probability for that x value. So 1 minus 3 times 0.2 plus, and then I'm going to do it with the next x value, 2 minus the mean squared times 0.5 plus next x value, 4 minus the mean squared times its probability, 0.2, plus 10 minus 3 squared times 0.1. That formula is on your page, and so you could do it by hand. It's short enough that you could do this one by hand. It's about 2.53. If you do it on your calculator, and so you just write down that value, please leave a little bit of explanation. I used lists in my calculator and did one variable stats. Just indicate how you came up with that number, because otherwise, I don't know if you just looked at your neighbor's paper, right? Give me enough that I know how you did this. How would we interpret that? Yes, and I don't have a lot of space to write, but that's absolutely perfect. The average amount of profit that Picard Partners makes on on major investments typically varies by about 2.53 million from the average of 3 million. All right. Picard owns its source of capital, a fee of $200,000 plus 10% of the profits X. So the firm actually retains Y equals 0.9x minus 0.2 from the investment. Use a linear transformation of your results in A and B to find the mean and standard deviation for Y. Woo. This one is the one that gets students every time. This we did back at the beginning of this module, so before break and even before that, because it was at the beginning of chapter 6. When you multiply, does it affect the mean? Yes. Does it affect the standard deviation? When you multiply, yes. When you add and subtract, it doesn't affect the standard deviation. So to find the mean for Y, I'm going to do 0.9 times, what was the mean of X? 3. Minus 0.2. I get $2.5 million. For standard deviation, sorry, not standard deviation of X, standard deviation of Y, 0.9 times, what was the standard deviation before? 2.53, and do I minus that 0.2 from this? Don't minus the 0.2. You do not do any adding or subtracting if it's a linear transformation of the standard deviation. So I'm taking this equation right here. We're doing the 0.9 because we multiply and divide for our standard deviation when we have a transformation. But we do not add and subtract on the standard deviation. My standard deviation is not going to become wider or narrower for a plus or minus. It's just going to shift. I got 2.277 million dollars. right, just a tiny bit of time left. What other questions did you guys have for me that I can answer in about 5 minutes? Oh no, that's no bueno. Couple tips that I can give you guys. Please make sure how to tell your different distributions apart. We talked about 3 different types of distributions in this chapter: binomial, geometric, and normal. Then we also talked about just distributions for random variables that don't fit that, but they have to give us a table. If they don't give us a table, we're dead in the water, if it's not one of those 3. When we are thinking that it's binomial or thinking that it's geometric, you have to check your conditions. You have to do bins before you could say, yes, it's this or yes, it's that. Please make sure that you know your transformation rules for mean and standard deviation. You're allowed to multiply or divide for both of them. You are only allowed to add and subtract for the mean. That does not happen for the standard deviation. Yes?
Transformation, will we give the equation to you?
You'll have to be given something for that, yeah. They might have it out in words, but it wouldn't be quite this confusing. They would have something that feels equation-like to do that. 10% condition. You guys feel reasonably comfortable with how to check that. You are almost never going to know the size of the whole population. But what you will know is the size of the sample. If you multiply it by 10, and you could make an argument that that community, that population is that size or bigger, then you meet your 10% condition, which gives you independence. Law of large counts. We touched on this for like this much. It comes into play much more in second semester. Law of large counts is what lets you take a binomial distribution and say, it's approximately normal. We didn't talk about it a whole lot. I do want to go over what that large counts condition is, but I would not spend tons of my time studying this. I'd read over it, make sure I know it, but I wouldn't do like 37 million practice problems on it or spend too much time on it. Law of large counts, or law of large numbers, is when I do n times p has to be greater than or equal to 30, and n times 1 minus p has to be greater than or equal to 30. If I meet those conditions, then I could say that this is approximately normal. I wouldn't worry about that a whole lot here. For the most part, if it says it's normally approximated, you're going to use a normal distribution. If it asks you what the distribution is, you're probably looking for either geometric or binomial or a neither situation. I'm probably not going to ask you to do a short answer on a neither because you can't go past the first step, but I would probably expect multiple choice questions to be hitting on some of those ideas. Can you tell the difference between these different distributions? We got a minute and a half. Yep.
Okay, so for like the mean and standard deviations for like the tables, if we did it on a calculator for the mean as well, you have to just indicate like did it on a calculator.
Yeah. Just say put X values in list 1, put probabilities in list 2, 1 variable stats, mean equals blah. Yes, I would absolutely accept that. What they're much more interested in on the AP exam is not so much can you calculate, although they do want to see that, but I would say percentage-wise, that's like 25% of what they want to see, and more of what they want to see is can you tell me what it means? Because for the most part, people who work in statistics professionally, they've got computer programs that calculate all of these things for them. A CEO can run these numbers, but the CEO has no idea what they mean. You make bank if you can explain what it means to the CEO and the decision makers. So that's what they're looking for. Can you interpret these things? Do you understand what these values are telling us about the situation? Right? Awesome. Well, good luck studying tonight. Please let me know over the evening if you have any additional questions pop up. Send them to me in Canvas. I'm going to be taking my daughter to gymnastics today, so I'm going to sit there and watch her, and if you have questions, I can answer them while she's doing her tumbling or not paying attention to directions or whatever else she might do. Have a good one. Yes, I'm after for a half an hour today.